All right, everyone. Good afternoon. I wanted to go ahead and get started with section 8.2, multiplying rational expressions. We'll do this pretty quickly, give you a chance to do a little practice. We'll get going. So our target is you can multiply and simplify rational expressions. So we're going to be looking at some fractions, and we want to be able to multiply them, divide them, and simplify them. We should say that divide is going to be in here also. So that's on the back page. All right, so when working with rational expressions, it is often helpful to simplify the expressions first. So throughout this year, we practice lots of factoring. I told you it was never going to go away, and it is not. Here it is again. The final skill of the year, can you factor? So these skills can be used to simplify rational expressions because common factors in the numerator and the denominator can be canceled out. So if I find a common one in the numerator and the denominator, now it has to be exactly the same. That's when I can cancel them out. For example, example letter A, if I look at the numerator and I factor it. Now, our process was look for a GCF first. So I see they both have a 2 in common, and they both have an x squared in common. And that'll leave me a 4x minus a 1 on the top. When I go to the denominator, I'm going to switch to blue. I have to be able to factor that as well. I'm looking for a GCF. They both have an x in common. So I'm going to take out the x, and that's going to leave me a 4x minus a 1. So I had 2 x's. I took 1 out front, so that left 1 inside. So then, do you see that these two factors are exactly the same? So I mark them out. And then I see I have 1x here and 2 x's here. So this one will go out, and that'll take that one down to a 1. And our final solution then is 2x to the first. And that's a simplification of a rational expression. Wonderful. All right, let's go to the letter B. I do have to factor the numerator. There is no GCF. I'm going to look for special cases. There is a special case here. This is a difference of 2 squares. So x minus 7 and x plus 7 is the factor of the numerator. And then we're going to factor the denominator. No GCF, no special case, so I'm going to look to see if I have factoring pattern. I have a plus and a plus, so my factors will have a plus sign. X times x is x squared, and I need a product of 7 that adds up to be 8. 1 times 7 is my only choice. Does 7 plus 1 add up to be 8? The answer is yes. So there we go. The two then that are alike, one at the top, one at the bottom, there they are. These two are not. I can only cancel out the entire family, so I can't cancel out an x and an x. It's an x minus the 7 has to cancel out an x minus the 7. So my solution is what's left over. X minus 7 on top and x plus 1 on bottom. Now, leave the parentheses. Leave the parentheses. If you start to write it without that, then you will mark out the 2 x's thinking that you can, but you can't. So here's the solution. Next part, multiplying and simplifying. Exact same thing. I'm going to simplify both numerators and denominators if I can by factoring. If I can't, then I'm just looking for common factors. The only thing that I will encourage you to cross simplify are the numbers. Leave the variables alone. In other words, I see an 8 and a 12 and a 14 and a 26. Well, 8 and 12, they have a common factor. 4 goes into 8 2 times, and 4 goes into 12 3 times. And then if I look an opposite direction, now I can look up and down with any top, any numerator, any denominator, any top with any bottom. This one has a 2, so 2 goes into 26 13 times, and 2 goes into 14 7 times. And I look around, I don't see anything else that will go into each other, so I'm going to multiply 2 times 7 and get a 14, and a 3 times a 13 and get a 39. And then I'm going to go ahead and multiply the variables. X cubed times y to the fourth. They are not the same, so they do not change any value. X and y times x squared. So x times x squared would be x cubed. Remember, you add the exponents and then a y. Okay, so the last part I haven't finished. I didn't simplify the variables. So when I get to this point, the 14 and the 39 will stay just like they are. I just make sure that I didn't miss a factor that'll go into both of those. I didn't. And then I'm going to simplify my variables. X cubed and x cubed take each other out. Now this is y to the fourth and this is y to the first. And remember, we subtract those exponents. So we're going to bring this one to the top. We'll do y4 minus 1, and we'll be left with the y cubed at the top. And there's my solution. We're going to get this one out of the way. I put it in the way here. All right, moving on. So when I get to example B, I see that I'm just not looking at numbers to cancel out. I'm going to have to factor it first. So these were all monomials. There's nothing that could have been factored. But when I get to letter B, I have to factor each part. So I'm going to factor this. This will factor to x and x. My signs are minus, minus, so I need a plus and a minus, and I need a product of 16 that adds up to be 6. It's either 1 and 16, it's 2 and 8, and I see it, so I'm going to stop. I need a negative 6, so I'll do the negative 8 and the positive 2. I'm going to drop to the bottom. I'm going to go ahead and factor out anything that's factorable in 2x minus 16. So GCF is first, so I'll take out a 2, and that'll leave me an x minus an 8. Then I'll put my times. I'll go to this top. There is nothing that'll factor out of x plus 1, but notice that I put the parentheses around it because I want you to understand that they have to be kept together. So I put the parentheses around the binomial to keep it together as a family. When I go to the denominator, I have to factor it also. All right, x and x, signs are plus and plus, and I need a product of 2 that adds up to be 3. So 2 times 1 is 2, and 2 plus 1 is 3. Okay, now, any numerator and any denominator that are exactly alike, I can mark them out, but only one time. So if I see an x minus 8 and an x minus 8, take them out. Then I see an x plus 2 and an x plus 2 on the other fraction. Well, it doesn't matter whether you're up and down or whether you're diagonal, as long as you're one top with one bottom, I'm going to take it out. Now, and you can only mark it out one time per. So one at the top, one at the bottom, mark it out. If you had 2, you would have to have 2 of the same factors to mark them out. Now, I see another one, x plus 1, x plus 1. Now, absolutely everything at the top is gone, so I know that place has to be filled with a 1. It's not empty. A placeholder is a 1. And what I have left at the bottom is just a 2. So my simplification is 1/2. It's really fabulous to do this. It's really even kind of fun. Sorry, it is kind of fun. All right, let's go to the last one, letter C. Okay, so let's go to this top one, and let's factor that. So to factor it, I need 2 parentheses. I need an x and an x. My signs are plus and minus. I need a product of 8 that adds up to be 7. So we're going to go with 8 times 1, but I need a negative 7. So I need a negative 8 and a positive 1. Denominator. All right. There are not 3 terms, so I won't be doing the factoring patterns. This one's going to have a GCF. I see I can take out a 3, and I can take out an x. Right, that's going to leave me 1x here, and 3 goes into 24 8 times, and I took the x out front. Okay, then there's times. This top, there's nothing that'll factor, so I'm going to leave it as 4x cubed. And then the denominator, this is a tricky part because students don't see that it's factorable. We've forgotten the difference of two squares, but that's what this is, perfect square minus perfect square. So it's x minus 1, x plus 1. Now, any numerator with any denominator, I'm going to cancel out. Okay. X plus 1, we'll take this x plus 1. X minus 8, we'll take this x minus 8. And then I have a 4 and a 3. Okay, they don't match. I don't have another x minus 1 at the top. But I do have an x to the first and an x to the third. So I have 3 x's on top and 1 on bottom. So I can take this one out. I just have to take this one down 1 power. Now, what's left on top is a 4x. And what's left on bottom is a 3. Remember, we canceled that one out. And an x minus 1. You do not have to multiply anything together. Leave it just like that. All right, we've taken a look at the multiply. There's one more on the other side that's just a little bit different type of multiplication problem, but it's still a multiplication. First part, this x plus 2 over the x plus 3, there was nothing to factor. However, the second part, there is. So it's times, I'm going to put it over 1, and then I'm going to factor this polynomial. So it's x and x, plus and plus, and I need a product of 9 that adds up to be 6. So 3 times 3 is 9, and 3 plus 3 is 6. Perfect. Okay, I have everything factored. Do you see that you have, and I always start with the top. There's nothing to take an x plus 2 at the bottom. There is an x plus 3 that takes an x plus 3. But like I was saying before, it has to be 1 to 1. So you can only take one x plus 3 with one x plus 3. This one has to remain. I don't have one to mark it out. I'd have to have another one at the bottom. So what I'm left with is these two factors at the top, and you do not have to multiply them out. X plus 2 times x plus 3 is my solution. And that's how I multiply two rational expressions. Now, down at the bottom, the last part that we need to look at in section 8.4 or 8.2, day 1, is I need to know how to divide these also. Now, if you don't remember from your 4th grade math, that's where this is taught, let me give you a quick reminder how to divide things. So dividing by something is the same as multiplying by its reciprocal. And reciprocal means you're going to flip it upside down. So if I give you a 2/3, its reciprocal is 3 over 2. That is its reciprocal. So when we divide, we actually are multiplying by a reciprocal. And then the exact same thing that we did in 4.2, the first part, becomes accessible here. So when we divide a rational expression, we must change the problem so we are multiplying by the reciprocal, but this is important, of the second expression. Okay, it's the second only. You can't change your mind and take the reciprocal of the first. You must take the reciprocal of the second. Okay, so in order to do some dividing, I'm going to do the exact same process that I did before. However, I'm going to change my question, and you can get faster as this. I'm going to do the first one a little bit long. It's x squared plus 6x minus 27 over x minus 3. And then I'm going to change it from divide to times, and I'm going to flip these over. The x plus 4 will go to the top, and this x squared plus 11x plus 18 will go to the bottom. And then it becomes the exact same questions that we had earlier in our notes. So what I'm going to do is go to this first one, put parentheses around it, and I'm going to factor it. All right, so here are my two factors, plus and minus. I need a plus and a minus, x and x, and I need a product of 27 that adds up to be 6. We're going to use a 9 times 3, and I need a positive 6, so I need a positive 9 and a negative 3. Denominator, there's nothing that will factor, but I am going to put the parentheses on it to keep it together as a family. Then we have a times. My numerator, nothing will factor, so I'm going to put the parentheses on it to remind me to keep it together. And then I'm going to put parentheses around the denominator, and I'm going to factor it. X and x, plus and plus will give me two factor signs of plus and plus. And I need a product of 18 that adds up to be 11. So 9 times 2 is 18, and 9 plus 2 is 11. Okay, now any numerator and any denominator that is exactly the same, cross them out. But only one time, remember. So here's an x plus 9, and here's an x plus 9. One at the top, one at the bottom. Here's an x minus 3, here's an x minus 3. I don't have an x plus 4 at the bottom, and I don't have an x plus 2 at the top. So therefore, my solution is x plus 4 at the top and x plus 2 at the bottom. And that is the division. Now, you're not telling me any exclusions. We're not graphing. I don't need x-intercepts or y-intercepts. I just want to be able to divide these two rationals. Okay, here's the last one, I think. Yep, last one. All right. The first thing I'm going to do is see if I'm going to do this one a little bit differently. I'm going to put a 1 underneath this and make it a rational expression first. Then I'm going to take the x minus 3. I'm going to put parentheses around it. I'm going to take the 4x plus 20, put the parentheses around it. I'm going to change this to times, and then remember, I have to take the reciprocal of the second. Now, this one will become 1 over x squared plus 2x minus 15. All right, that's it. That's the only thing I have to remember that is different about a multiplication and a division question. Then I'm going to go back and I'm going to factor. Well, there's nothing to factor here, but there is in the denominator. There's a 4 and a 20. They have a common factor, a GCF of 4. So I'm going to take that out. It's going to leave me a 5. The 1 is going to stay on top, and then I'm going to factor the denominator. X and x, my signs are plus and minus, so I need a plus and a minus, and I need a product of 15 that adds up to be 2. So I know that 5 times 3 is 15, and 5 minus 3 is 2, and I need a positive 2, so I'll put the positive in the 5 and the negative with the 3. Okay, and then I'm going to mark out any that are alike top and bottom. X minus 3 takes this x minus 3. Now, do you see that the x plus 5 and this x plus 5 are both in the denominator? So therefore, you can't mark them out. The 1 is left on top. Let me go back to red, sorry. All right, the 1 is left on top. So I still have a 1 on the top. And at the bottom, I have a 4, and I have an x plus 5, and another x plus 5. Now, if you are going to take your SAT this year, this is one of their favorite things to ask you. They want to make sure that you understand that if you have 2 of these, that you can write it like this. And therefore, this is now my solution. Okay, so today we have talked about multiplying rationals, simplifying rationals. So the simplifying leads to the multiplication, which then leads us to the division. So the only difference between simplification, multiplication, and division, we've got to know how to factor. So there is some factoring practice that we skipped over You are more than welcome to go back and complete this factoring practice. We just don't have time because we only have 4 classes left this year with our e-learning going on. So this is your assignment for today. So please, 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 please do worksheet number 5. If you can't simplify these, you're going to have trouble with the last 2 lessons that I have to teach for you. Okay? If you have any questions, remember you can always set up a time with me. I'll be happy to Zoom call or Google Hangout, and I can answer your questions if you have them. You just make sure you let me know. Okay? Be well, everyone, and I will see you soon.